All right, so we have learned the disc/washer method, correct? Okay, now I have a question.
We have answers.
If this is your region, and I asked you to rotate it about the y-axis using our disc washer method, what would the issue be? Well, we'd have to use y's, and why would it not be fun? Okay, we would have to split it into two different integrals because the function on the left changes partway through our region. So we would have to do two different integrals.
How?
Okay?
If it's so right to left.
Closer to point.
Oh, it's one's touching.
Okay, so this one is
Yeah.
the parabola, this one is
Yeah.
the line. Okay? Now, what if we could do this, but with vertical reference rectangles? That would be better, right? Obviously, we wouldn't be making washers anymore, but if we could use vertical reference rectangles, we would only have to do one integral. So, today we are going to talk about the shell.
Oh.
Rookie. Can you use the magic?
Now, let me ask you this, okay? Because I'm teaching you another method, and so we're going to have to keep them straight, all right? One way to keep them straight is to actually visualize what's happening, okay? But some of you like some play on words to help you remember, okay? When we use the disc or washer method, what are our reference rectangles compared to the axis of rotation? They're perpendicular, okay? And so in our shell method, they are going to be parallel.
Parallel park.
Okay? So this is how I sometimes ask students to remember it. Perpendicular or parashell. Okay? Now obviously the washer's not thrown in there, but we know the disc and the washer method, they're one and the same. Right? So if you need a way to help you remember it, perpendicular and parashell. Okay? However, I think it's going to be best for you to visualize what's happening as well. Okay? So let's talk about the shell method and what it's going to look like. So we're going to get a region, and we're going to break it up into these infinitely small rectangles, and we're going to take these rectangles and we're going to rotate them about the axis of rotation. So you see now that we have parallel rectangles compared to our axis of rotation, these really thin rectangles twist around to create a cylinder, if you will, or a shell. I'm not in charge of naming it.
A shell, like natural seashell.
Or like a shell casing around. I mean, it looks like a bunch of koozies, if you will.
Oh. Yeah, that's
They're
crazy.
Okay. Okay, so we visualized it, we see it. Okay, we'll watch it one more time.
No, I'm a little baby.
Okay.
No.
Ready for it?
Okay, so let's talk about that shape right there, okay? We're going to unwrap it, and it's basically this big rectangle, right? So let's think about the dimensions of this rectangle. If I took this and I unwrapped it from this cylinder, what is this measurement right here?
Length.
Would be circumference.
It'd be the circumference, because that is what was wrapped around the circular base, right? Okay, and then we have the height, of the cylinder, and then we have the width, which is going to be either our dy or dx, because these are going to be infinitely thin rectangles that we're rotating around. Okay, so essentially, to find the volume of one of these shells, okay, I'm not going to the next slide.
Oh,
Okay. To find the volume of one of these shells, we've taken it and we've made a nice rectangular prism. How do you find the volume of that rectangular prism? Multiply those three. So the volume of our shells are going to be 2 pi r, that's circumference, times height times width. Okay. Now, width, you told me was going to be what? Dx or dy. Okay. So what we have to do is we have to figure out what is the radius and what is the height.
Radius
Okay.
will be the distance from our axis to our outside of a rectangle.
Outside,
Well, you take the circumference divided by 2.
or outside
What?
washer.
Whoa, is top minus bottom.
Oh, wait, no.
Okay, the height is going to be the height of our rectangle. The radius is going to have to be how far are those rectangles from our axis of rotation. Okay, yes, you're on the right track. So let's get a visual here. Okay.
Whoa.
So here's our visual. I know there's a lot going on. Okay, so the radius, how far are these rectangles from our axis of rotation? I'm going to draw a new picture up here. And that's the picture that we've been working with, right? Okay.
Oh, I see your show now.
So our radius is going to be how far are each of those rectangles from the axis of rotation.
Outside point of those rectangles, right? They're not very small, so.
Right. And they could be anywhere lined up in here, right? And so what is the distance in general from here to 0? Here to 0, x. They're all going to be x away. Does that make sense?
Yes.
Okay. If this is x is 2, 3, 4, whatever it is, they're all going to be x away. All right? So x is our radius. And then our height is going to be, in this case, top minus bottom. Okay? How tall are each of those cylinders? How tall is our reference rectangle?
So that is like, this will
Okay. So this is the formula for the, the shell
Is
method.
H the minus or what?
The height is f of x minus g of x, top minus bottom.
it's finding the distance between the points.
It's finding that length of the rectangle, the height of the rectangle length, however you want to think of it.
Well, no.
Okay, so you can see that this one could potentially be nicer to integrate by hand because we don't have to multiply anything. Like if we have a binomial squared in the disc washer method, sometimes it's kind of a hassle if we have to do it by hand. Here, there's nothing squared, and so that helps the ease of integrating by hand.
So does it always top minus bottom? Like,
For the last right, you know, the challenge.
I'll let you rephrase that.
Right, so.
Right minus left. Okay, so we're going to do a couple examples in terms of dx first, and then we'll look at when we have it and our rectangle for
When
dy.
doing the show method from dx, you do right to left. Is that?
No. If we're doing the shell method with respect to x, we're still doing top minus bottom to get the height of our rectangle.
Oh, I see.
we can do the same process for y's to replace all the x's with y's.
Right, so, but let's master this first, and then we'll talk
Yeah.
about doing it in terms of why. Okay, but yes, you are on the right track. Aaron, did your question get answered?
The guy's got my question.
So it's apparently not an issue. Okay, are you guys ready? All right, so,
Whoa, hold on. Let's just watch this first.
okay. Find the volume when the region of 0.05x and 1 minus x minus 1 squared is rotated about the y-axis. So, it's that region, right? So x minus 1 squared, the quantity squared, that's a parabola that's been shifted, right? And then y equals 0.5x, what's the slope?
Very bad drawing.
Don't hate.
Thank you.
That's pretty good drawing.
Got you.
Okay, we need to figure out, first of all, what our intersection points are. Well, maybe that's not what our first thing is. Let me draw my reference rectangle here. We're rotating about the y-axis, and I want to use shells, so our reference rectangle is going to be parallel to that y-axis that we're rotating around. Okay? Do I need to get that out of here? Is this distracting?
No,
I'm gonna give me.
What? Maybe to Jimmy?
I'm gonna give me.
So this has thickness dx, which means we need to know these x coordinates right here. Okay? How are we going to figure out what those x coordinates are?
7 equal to each other.
So x squared minus 2x plus 1 needs to equal 1/2 x. What multiplies to 1 and adds to negative 5/2?
-2 and -1.
Negative 2 and negative 1/2.
Boy, car.
Nice work.
Taper.
So 1/2 and 2 are our points of intersection. So our integral is going to go from 1/2 to 2. Now, let's think about these cylinders. Remember, we have 2 pi RH, right? Dx. Okay. The radius. How far are each of these rectangles from our axis of rotation?
1.
They are all x away. Okay? All of these rectangles are x away from the y-axis. That's their distance from the y-axis.
So
It's
just
x.
the integral between 1/2 and 2.
No, we're not done yet. Now we need the height. Now what's the height of each of these rectangles?
0.5x minus x minus 1 quantity squared.
Okay? So we take our top function, 0.5x, and we subtract our bottom function, x minus 1 the quantity squared. Okay. So with your calculator, what I would probably do is I would integrate this, figure out what that fraction is, double it, and then multiply it by pi.
Wait, so if you're going around a y-axis, then because like for this and washes, we would use the integral from like y integrals, you know?
Right.
So now we use that.
Right, so now since our reference rectangles are changing directions, basically, the shell method, if it's dx, then the disk method would be dy.
Yeah.
Right, they're going to be opposites.
Okay.
Which gives you some freedom. If I give you a problem with no parameters as far as how I want you to go about solving it, you get to decide what what method to use, and if you want to do, is it better with X, is it better with Y?
And so like,
Yeah.
so now it's, if you go about the Y, now it's top minus bottom, and if you go about the X, then it's right minus left. That's those two.
So this is gonna give us some freedom, and we'll talk about that here in a second. Jimmy, what your calculator give you for an answer?
45 over 32 pounds.
I was about to say I got 4.418.
Well, that's more.
Or, did you change it to a fraction?
Oh, no, I did not.
Okay.
I don't think it.
Isn't it right?
Possible.
Before you multiply it by pi, change it to a fraction.
Oh, please.
Okay. Do you agree with Jimmy?
Who wouldn't?
Unfortunately. Don't say unfortunately. Josh, does that make sense?
Yeah.
Okay. All right, let's do another one.
37. Correct. That's the implication.
I didn't try that one more.
X equals pi.
Whoa, that does not look like it.
That looks like a table.
It does. Like a Roman table.
Y equals sine of X. What does that look like?
Middle zero.
Starts like that, right? Where is it hitting the x-axis?
X zero, pi over 2, pi,
At pi. Okay. So this is what I'm concerned about. And it's bounded by this and the
0 and then 0.
y equals 0. So I can't highlight, can I? There. This is the region that we're worried about, right here.
Highlight.
I'm not using my smart.
No.
No.
So how are you recording it?
How am I recording it?
Is that just on the smart board itself?
No, it's whatever is showing up on my computer is what it will record. So I don't even have to have this hooked up. Like, I can be on a website and I can press record and it'll record everything that I'm doing. It's actually kind of cool. All right, so here's my reference rectangle with thickness dx. We're going to rotate it about...
Of course you're in.
Thank you.
Where are you?
So what is this going to look like?
Like a donut, but chopped in half. And what?
Okay, I will, yeah.
You see someone's butt cheek?
No, it's gonna look like.
Like, it's gonna look like a bundt cake without the hole in the middle, right? That's what I want you to picture. That's what I was trying to go
Oh,
with.
like angel food.
Oh, yeah.
Like a
You look like Andrew.
Okay, you guys will actually, the day after your test, I'm actually gonna bring in a bundt cake and you're gonna figure out the volume of my cake
Oh,
pan.
we're gonna eat it.
What?
And then you get to eat it. Yes.
Yeah. Can't we just eat it and find the volume of
Our
work after we get
Okay. So, first of all, since our rectangles are parallel to our axis of rotation, we're going to have shells. I want you to imagine this rotating around. Can you visualize that shell?
Yes.
Okay, you need to be able to visualize the shell or visualize the disc or washer, okay, so you know that you are sure about the method that you're using, okay? So, we know we need 2 pi radius height dx, okay? And we know it tells us we're integrating from 0 to pi. Now, since our axis of rotation is the y-axis, what is the radius for each of these x? Okay. And how do we find the height of each of those?
Top line ball.
When we are rotating about the y-axis, yes. The radius will change tomorrow when we're rotating about when we're rotating about other lines. Okay, but we'll save that for tomorrow. All right, now this one we have to do with our calculator. It's probably not going to give you an exact answer, so you're going to have to multiply the pi to the decimal that you get.
I got 19.739.
0.74.
Well, what's after the 9?
39,622.
19.
So if the number after the 9 is less than 5, then this is what we round to.
I do not know how to round.
Okay, now, why is the shell method the only one that we can use here?
Because we can't find the right minus left of this graph.
Because it's just the same function.
Okay, yeah, there's no way to do a horizontal here, a horizontal reference rectangle.
Are you sure? We could go to half.
No, like, I'm telling you, you can't. All right, we can solve for y, but the inverse sine of y only is a piece of that. Okay,
Oh,
the inverse sine,
because it's not like a y squared.
the inverse sine looks like that.
That looks like Sandy.
Hold on. Anyway. All right, let's do.
Keep it shuffling.
Okay, so before I move on from this, it's not what we're gonna do. Okay, this gave us a way to do this problem. Without the shell method, we would not have been able to do this with the dishwasher method. Okay, so there's going to be some problems where you can only use one or the other. There's going to be some problems where I'll tell you what to do. There's going to be some problems where you have the freedom to decide. Okay? Let's do this one.
Are you sure? Are you sure you really can't split it in half and then you said you can't split it? I'm saying like splitting the intervals in half, like going from.
But you can't. But that's not the graph of inverse sine of y.
But it has to do with the inverse. This is the inverse.
Because if you're gonna do it with the dishwasher method, it would have to be in terms of y. So you'd have to solve for x.
Why would I have to solve for x?
Because if you want horizontal reference rectangles, they would have to have thickness dy.
Yeah.
Which means you'd have to integrate with respect to y.
Okay.
Which means you would need equations for those. And you can't do that because the inverse sine.
You can still use the equation of sin x.
No, because you have to solve it. It has to be in terms of y. So you have to solve it for x. So it can be in terms of y, so you can integrate with respect to y.
Okay.
Okay? Think about it, we'll talk later. So y equals 4x, y equals x squared, rotated about the x-axis. You agree that that's what our region looks like?
Okay.
Not a beautiful drawing, but that's what's happening, right? What? What's this coordinate?
0 and 4. Not 2 4s, it goes.
When does 4x equal x squared?
Wait. 4.
So 4, 16. Okay. We want to rotate about the x-axis.
Can we just do normal dx here?
If we were going to use the dishwasher method, yes. Yes, we could. Okay? Now, here's the thing with... Okay, yes, you can use the dishwasher method, but what are we're doing the shell method, okay? So,
Not complication.
here is my reference rectangle with thickness dy. Okay, the beauty of math is sometimes we have more than one way to do something. Okay, so our volume, 2 pi RH thickness. Okay, so we're integrating with respect to y. What are our limits of integration?
0 to 6. 4.
0 to 16 with respect to y, with respect to y. Our radius, how far are all of these rectangles away from the x-axis?
Y.
They are all y away from,
Will they always be Y or X?
as long as you are rotating about the x or y axis.
Because that means we need to change the original function. Because the original function, we said b equals 2 pi n times the integral of a to b of x quantity f of x minus g of x.
Okay, so how we, basically what we're doing here is 2 pi c to d of y times f of y minus g of y.
Yeah, but what I'm saying is if you rotate it around an axis that's not 0.
Which was what we're doing tomorrow.
Okay.
This is what we're doing tomorrow. Okay. Our height. How do we figure out the height of that
Right, that's right.
right minus left? So what's on the right?
Square root of y.
Ah, square root of y.
Oh, whoa, tiny button.
Minus, what about this line?
0.25 y. That's the same thing.
You see y over 2?
He said 0.25y, which is the same thing as 1/4 y, which is the same thing as y over 4. I don't care how you write it, just write it.
Yeah, it's easier plugging in content.
No.
Okay, this is probably going to give you
It gave me
something.
32 over 3.
428.
Wait, hold on, I got times 5.
So it's a fraction in terms of.
64 over 3 pi.
I got
I already got my worse.
Disagree.
You disagree?
Yeah.
You disagree as well. What did you get, Nathan and Aaron?
Or 28.932. No, you got?
What did you get?
I got 4.8.
Yeah. Thank you very much.
So it wasn't the,
I got
428.932 because they're dropping.
limit divided
so it didn't give you something in terms of a fraction?
No.
I got 2048 over 15 pi, which is then.
Excellent. Okay. Okay, now, Josh pointed out, it can't always be x, it can't always be y. Tomorrow we will have to adjust this formula a little bit, but for right now I want you to get into the habit of your radius is going to be either x or y because that's the distance from the axis of rotation. We'll adjust that tomorrow. And then the height of the cylinders is always top minus bottom or right minus left, just depending on what you are integrating with respect to. Now, when you do your homework, I want to see those reference rectangles, okay? I want to see that you're thinking about where you're rotating it. Okay, anytime you draw a reference rectangle, I would suggest labeling it as dx or dy so you know. Okay. Here's your homework. Let me open my book and take a look to give you any pointers. And we're writing here. Okay. So I'm giving you 1 through 11 on and 15 to 21.
I have 0 followers on Pinterest.
That's amazing.
Okay, so these are the ones I do want you to perform by hand. 1 and 3 do by hand.
Wait, 1 and 3 we just got set about.
Oh. So do it by hand. Set it up by hand.
And evaluation.
Oh, dang it.
Oh, and.
So 1 and 3 I would like you to perform by hand. 16 I'd like you to do by hand.
16?
Yeah.
Is that it?
Yeah. Yeah, that could be good.
Which one?
Yeah, the bag is like,
160.
yeah, I should.
It is gnarly, yo. Yeah,
I've had it since 15 years.